Perfect. Thank you. Thank you for giving me the opportunity to talk here. So I will look from a bit different perspective because we are going to talk about the chemical plating now. And so what I'd like to talk about today is autocatalytic autocatalytic properties gives new opportunities for new applications, in particular also for micro LED applications. I will start with a brief introduction on the background, why we looked into this. We'll then show more details about our plating solution. And yeah, we'll end with a brief key takeaways. Let me start with the background. um, yes, so the tin layers are a widely used finish in the PCB industry, and immersion tin is widely used, in particular in automotive, has a good reliability, has a good solder joint reliability, good solderability. Nevertheless, there are certain limitations because it's an immersion process or a replacement process. We have to dissolve the copper of the copper tracks to deposit the tin. We have a certain limitation in thickness because the thicker the tin layer gets, the less copper can be dissolved. And with that, you have a limitation of about 1 to 1.2 micron that you can deposit. And at the same time, it's also limited to the copper substrate. So we can only deposit immersion tin on copper because you simply need to have the replacement reaction. And because you dissolve copper, it's also a limitation in regards to fine structures. If you have very fine copper tracks and then you immerse to an immersion tin electrolyte, then the tin will dissolve some of the copper. And if you have really fine tracks, then the copper the structures, actually the designs, might be destroyed. So therefore the approach was to look for an autocatalytic process to add some reducing agents to be able to deposit tin without attacking the underlying metal. um, and additionally, this brings a benefit that we can actually deposit higher thicknesses as well. So when we look onto the benefits of the autocatalytic process, there are several ones. So you can deposit high thickness with a, let's say, a deposit to deposition rate of up to 5 micron per hour. Um, you have a you are not limited to the underlying metal, so you basically can deposit on any metal you'd like. So we have actually done platings on copper, on palladium, on nickel, on gold layers, on silver layers. And you can deposit high thicknesses, so you also can kind of deposit some solder bumps, solder depots by the plating process. And additionally, the process comes with a regeneration concept where I will show a bit more details later on. So, brief process description. As mentioned, the deposition is really fully autocatalytic. So we have a reducing agent inside which provides the electrons for the tin deposition. We can deposit about 3 to 5 micron per hour, and it's also there are no heavy complexing agents, no toxic substances in this electrolytes. Target benefits: different metals or deposition on different metals is possible, and actually what possible applications are and where the process has been applied already is, for example, for micro LED, but also for IC substrates for the BGA, um, and for depositing solder bumps, or also plate bumps on glass substrates, even for QFNs to deposit the side flanks, to deposit tin on the side flanks of the QFNs. So there are a couple of, let's say, applications where the process can be used for. How does a tin layer looks like? From a top view, it's actually pretty standard tin deposition. But when we look at the from the cross section, then we see that we have really big tin grains here. So this is a approximately 5